All right, so this is the recording. Hi, my name is Mr. Shanklin. I teach Algebra 1, Algebra 2, pre-college math, AB Calc, BC Calc, and I also do the student service learning. Um, I am going to talk through how this class is run. How many of you guys watched the lesson tutorial before you came in today? Okay. All right. How many of you did not? Samantha, the lesson tutorial? All right. The math thing, that is, yes. Well, did it explain this week's material? Yeah, exactly. Yeah. So, yep, section 1.1 and 1.2. Now, if you didn't, I would highly recommend that each week, if you're coming to the main lesson, that you watch those. Okay, and you don't have to. I mean, it's some kids are like, yeah, that, I understand this stuff. I don't need to watch that. That's perfectly fine. However, some of you are going to be lost if you don't watch it, because what we do during the class each week is I'll spend maybe 5 minutes going through the lesson tutorial, what we're doing for that week, but that's it. And then we're going to work on the practice problems. And the reason is, I used to spend, I've been doing this for a long time in the math department. We used to do a lesson. Our main lesson would be just going over the material for the week. And kids would never be able to ask questions. They wouldn't be able to do the practice problems or anything, because we'd go from bell to bell, just going over the lessons. And it's like, why are we doing this? Why don't we just send them the lessons and they can watch them, and then if they have questions during the main lesson, you can ask your questions. And we also go through every single problem off of the practice for the week. So for those of you that don't know, every week you have a practice. It's 10 questions. It's multiple choice. And when you finish the practice, if you get an 80% or higher, then the assessments will open up. So you can't take the assessments until you show me that you understand the practice. Now, since we go through every single problem off the practice in class and go through all of the answers, guess what? You should never fail the practice, right? You should always get a 10 out of 10, because we're going to go through every problem off the practice today in class. So you will never, ever go away from this class not having all of the answers to the practice. And then I will also discuss at the very end the assessments for the week. Okay? Every week you will have 2 assessments. One of them is a free response where you have to work out the problems and show me your work, and the other one is multiple choice. And yes, you do have to show your work. Okay? Yeah, so e-sessions are huge, no question about it. All right. So let me go to the next slide here. This is week number 2. This is your pace chart. It shows what you're supposed to be able to do this week. It says, I can determine the domain, range, and end behavior of a function. Okay, that's one thing you should be able to do. I can identify attributes of a function and how they are related to the function's graph. Okay, so those are 2 things that you have to be able to do this week. Now, this is really important, and my kids in Algebra 1, they're like, really? When you are in an online class, this class, the only 2 things you have to do for this week is the week 2 practice, and you have to get an 80% or higher, and then it opens up the 2 assessments. That's the only 2 things you have to do. Everything else is here to help you do well on the practice and the assessments. For example, the week 2 lesson tutorial, that you should have watched already. That got you prepared for today's practice. And then after today's recorded main lesson, I will put that into here. So when you go to your pace chart, all of these should be live links. Now, this is a live link for this year's assessment or lesson tutorial. This is a live link from like 2 years ago. It's not. So once we finish today's assessment or today's main lesson, I will put that recording link in here. And then there's examples. Now, all of this stuff is stuff to help you do well on this week's practice and assessments. Do you have to do any of it? No, you don't. And that's where kids, they are like, oh, blows my mind. I don't have to do any of this. No, you don't. You don't even have to ever open your textbook. The textbook is there to help you. If you have questions, you can open your textbook, go through. But if you understand the material, like if I do such a great job today and it's like, whoa, that stuff is easy. You don't have to watch, you don't have to go to the lesson, the textbook or anything like that. You can just do the practice, do the assessments. Done for the week. Boom. That's it. But if you're struggling, you should watch the lesson tutorial. You should watch the recorded main lesson. You should watch the example videos. You should go to the lesson or the textbook and go through this week's sections. That's all there for extra help. Okay, so I'm hoping I'm making sense to you guys. If not, please, this is supposed to be your time to ask questions. So if you have questions, please ask. A lot of times when kids don't ask questions, I just keep going because I think, oh, they all know everything. Okay, awesome. Let's keep going. Okay, so the next thing I'm going to do each week, so the first thing is Algebra 2, boom. Next thing, we'll talk about the pace chart, what you're supposed to know by the end of the week. And then the next thing I'm going to do is I'm going to review the lesson material. I'm just going to spend maybe 5 minutes, and then we're going to go on and do the practice problems, okay? So that's how this class is set up. All right, so first thing, you have to be able to tell me the domain and range of functions, okay? I think it's pretty easy. Some kids, they don't think it's very easy. All right, so let's say I gave you something like this. Let's say I gave you a function that looks like this, that has a dot here, goes down to here, and then goes back up to here. And this is an open dot here, all right? What is the domain? What is the range? Domain and range. And what I'm really doing is I'm trying to get you ready for the assessment, because there's a problem just like this on the assessment today. It asks you what is the domain, the range, and what is it a function or not? Function or not, yes or no? Okay, so we'll go yes or no here. First thing you want to do, when I look for domain and range, I look for domain first. I look on the x-axis. This is the x-axis right here in red. Okay. How far over is the graph? Well, it looks like it stops at -5 here, right? And it looks like it goes to +8. That is my domain. Now, you have to be able to write it mathematically, and there's 2 ways we can write it mathematically. So this is a closed dot here. Okay, this is a closed dot. You can write it, oh, Samantha, I would say, parentheses, right. It should be -5, because -5 is a closed dot, which means that it is part of the domain. So that would be a closed bracket. And then 8 is an open dot. So that means it would be a parenthesis, because that means it's not included. All right. So this is one way to name the domain. That's one way. This is called interval notation. You can also use this. You can also say x is greater than -5. Oop, that would be x is greater than or equal to -5 and less than 8. There's 2 ways that you can. Do you put a comma? No, there should be no commas in there. Wait, so if the circle is filled in, we put a square bracket. Yes, that means that if it's a solid dot here, that means that -5 is part of the domain, okay? If it's so we would put a square bracket here. If it's an open dot, we would put a open brackets, meaning that, or parentheses, meaning that it's not part of the domain. It goes out to 8, but 8 is not part of the domain. So that's why we put that little parenthesis there. Okay, so these are the 2 different ways that we can say what our domain is. Okay, let's say, yeah, that's why we use the parentheses, so we don't have to do 7.99999. Okay, that is why we do parentheses, because it's like, how many 9s do we put down? All right, so that's yeah, the parentheses seems a little easy. What if I change this problem just a little bit? What if I did this instead? That this kept going, and there was an arrow there. It's just, so now what would the domain be? Positive infinity. So you're saying that this is it's a -5 to infinity, and whenever you use infinity, it is a parenthesis. Do you guys agree with this? That this is an okay way of writing it? Okay. How about this? Is that okay? So there's two ways you can write it. I don't care one way or the other. I like this, the bracket notation, a lot better than this, but it doesn't matter. I don't care one way or the other which way you write it. It makes no difference to me. So, go at it. I just think that the brackets, but remember, I am going to take off if you use a square bracket when it's supposed to be a parenthesis, okay? So that I will take off for that. All right. So now let's try. Yeah, you can do one or both. Right, you don't have to do both of them. You can just pick whatever you're most comfortable with, okay? So let's say I gave you another problem. Let's say I gave you this one. Oops, I have to turn my marker on. Okay. And it went down to here, and then it went to here. And this is let's go closed out again. Okay. Now, what is the range? If I'm asking for range, now it's the y-axis. I look at the y-axis. What is the lowest point in this graph? This is the y-axis. So what is the lowest point it ever goes? It looks like it goes to 0. What is the highest point it ever goes? I kind of messed this up. Let's go to 8. Okay. Yeah, I know it's hard to tell on my graph. We'll just say it's 8, okay? And both of them are square brackets. Excellent. So 0 to 8. I don't want the parenthesis in there. I don't know why I always keep doing that. Yes, the dot is huge. I agree with you. All right. So that would be the range. What if this thing was like this? And then what would my range be? 8 to infinity, right? So I would go 8 to infinity. No, I would not. That would not be right. 8 to infinity is not correct. Okay, because what is the lowest point? 0 is the lowest point. So this is my range. So 0 to infinity would be, so that would be my answer. Do you understand? Oh, okay. All right. Okay. So that's domain and range. Is this a function? Whatever I have graphed out here, is this a function? Yes. How do we tell? Super easy. It's called the vertical line test. If you could vertical line test. If you could draw a vertical line anywhere on the graph, and if it only touches it one time, anywhere, then it's a function. Okay, so if you drew a bunch of vertical lines, you would see that it only touches one time in all the places. All right, so let me give you a problem that I would put on an assessment that might drive you crazy. All right, so let's say I gave you this on your assessment, and there's one almost identical to this tonight. Well, that's not a bad circle for me. All right, what's the domain? What's the range? Is it a function? Okay, so that, if you can do that, not a function, I agree, it's not. Okay, it's not a function. If you can do this problem, you're going to have no problems with the domain and range tonight. D equals -4 to 4. I wouldn't. You got to put either brackets or something in there so I understand. Okay, so domain, I agree the domain is this. Okay, got to have square brackets there. Okay, and what is the range? Range is the same thing, right? Awesome. So if you guys got that, you're ready to roll on the assessment this week. However, you can't do the assessment until you do the practice problems, and we're not there yet. Okay, and then there's one other thing that you have to know for this week's assessment. Well, you have to know a couple things, but if I give you, let's say I gave you it was not a function, that is correct. Let's say I gave you something like this. Where is the function increasing? Where is the function decreasing? You read a graph from left to right, okay? Increasing just means what I mean. This is going up, okay? So this is So this graph is increasing from, I would say, negative infinity, because it keeps going, to, let's say, 3. Okay, so it's increasing from negative infinity to 3, and it looks like it's increasing from 5 to infinity. Oh, shoot, I keep putting parentheses in there. I don't know why I do that. Yeah, it shouldn't have been, man. I mean, yeah, it should go down like this. I didn't want it to be, I wanted it to be a function. Okay, so being able to tell if something is increasing or decreasing, that's what you have to do. All right, so every week I'm gonna basically go through the lesson tutorial just really quick. Does that mean you shouldn't watch a lesson tutorial? No, it just means I'm just gonna quickly go over it, so when we get to the practice, you'll know what to do. Okay, so now we're gonna go to the practice. How do we do practice? I just put a link into the chat box. I want you guys to click on that link, and I want you to go to that Desmos presentation. Why am I going to do that? Because this is my way of seeing if you guys understand the material for this week. And some of you are going to say, well, how are you going to tell if I know the material for this week? Well, guess what? I can watch you on the screen. I can watch every single student at the same time. So what I'm going to do is I need to share an application here with you guys here so I can see what you're seeing. Okay, so that goes there. All right. So what I'd like you guys to do, oh, who's that handsome gentleman on the paddleboard? That's your teacher trying to paddleboard his way home. I try to paddleboard almost every day. I love it. So let's go to slide number 5, okay? We're going to be on slide number 5. This is the first problem on your practice this week. Guaranteed. This is the first problem. Oh, it's so tiny. I don't know if I can make it any bigger. So I will read it to you. Okay. It says, find the interval or intervals where the function is decreasing. Okay. So where is this function decreasing? Now this is where you guys are supposed to show your work. Now this week there's a lot of problems that there's not a whole lot of work that you have to show. Okay. Really, I mean, how do you show work for this one? I mean, there's not a lot. I mean, what you could do, I mean, I guess you could do this. You could just take your marker. Let's do red here. So you could go like this. So it's decreasing here, and it's decreasing here. So I'm going to go from like -3 to 0. Oh, they have it in parentheses. I would have done square brackets, but they have things in there, so they're doing it a little bit different. But that's fine. We should be able to figure it out. And then 3 to infinity. Okay. Does that make sense? That would be my answer. Now, if there's no arrows or dots, if there's no dots at the very end, you just have to assume that this graph is continuing down, okay? Does that make sense? I have to say this again. If there's no dots, like a open dot or a closed dot, you have to assume that those graphs keep going down. Where did I get the 3? For the -3 or the +3? Decreasing. Both. Okay. So when I look at this graph, it's asking me where is the function decreasing. Okay. So this graph, let me change colors again. So this graph is decreasing where this purple line is, right? It's going down. So where did it start? It's your x-axis that tells you your interval. So it starts at -3 and it goes to 0. So this function is going down from -3 to 0. And then it also goes down from, looks like +3, and it keeps going here, so to infinity. So that's where I came up with the +3 and the, you're looking at the y. Yep. Whenever you're doing an interval, increasing or decreasing, it's always the x-axis. You're always looking at the x-axis. That is just when you, yeah, I'm out on the deck. Yeah, some of the birds are going crazy right now. Sorry about that. But no, whenever you're asked to find an interval, okay, it is always the x-axis that you're looking at. No, there's a couple crazy ones out there. All right, does that make sense? Can we go on to problem number 2, or do we still have questions? Because number 2, the interval means domain and x-axis. I'm not going to say that. I mean, it doesn't mean domain, but it does mean the x-axis is your interval. I mean, it does not mean the same thing as domain. It's close, Samantha. It's close, but I don't want to say that because some math teacher is going to come back and say that is not the domain. These are the practice problems. Yes, these are the exact problems of your practice. So if you opened your practice right now, this is problem number 1. So you should put letter what? Letter B for the answer. Is that correct? Yeah. So yeah, you should. If you had your practice open right now, you'd be seeing the exact same problem. Okay. I try not to mess with you guys. I try to tell you exactly what's going to be on there. All right. So let's go to problem number 2. Problem number 2, I think it's just where is it increasing now? To tell you the truth, I think if I remember my practice. Okay. So it says find the interval or intervals where the function is increasing. Okay. So now you guys could be in Desmos, and if you're in Desmos, let me see. Oh, you guys are all on. Most of you guys are on practice or problem number 2. There's just a few stragglers that are still on problem number 1. But I can see, and there's really no work to do here. So if you just circled the correct answer, that would be perfectly fine. Because in this problem, there really isn't a lot to do, right? There's just not a lot to do on a problem like this. And you just look at it and say, oh, it looks like from positive 3 to infinity, it's going up, right? So if I was doing this problem, I would say my answer is letter A. Do you guys agree that the answer would be A? Yeah, that's it. Not a lot of work. Now, let me tell you, in the next couple weeks, we have some problems that you're going to have to be working out on the board. You can't just look at it and say, oh, my answer is this. Okay, so yeah, this is a pretty easy week, I think, for domain and range. It's not that difficult, but we'll get harder. But every practice is multiple choice, so okay, every practice is multiple choice, so you don't have to worry about that. They're always multiple choice. All right, let's go to problem number 3 on the practice for this week. Okay. Oh, scatter plots. Oh, there's something that I forgot. So for those of you that watched the lesson tutorial, okay, for those of you that watched the lesson tutorial, did you understand how to use Desmos to graph linear functions? It was towards the end, correct? Okay, we'll do a little bit. We'll talk a little bit about it, okay, today. Again, I'll show you step by step how to do it if we have enough time at the end, which we should, because these problems shouldn't take so long. Okay, so problem number 3, it says the scatter plot shows the relationship between the weekly total sales and the number of different rug designs a rug store has. Based on the relationship, predict what the total sales will be when the store has 110 different rug designs. Okay, down here, number of rug designs. Up here, total sales. So if they asked me, they said that there's 110 rug designs, well, they're counting by tens here, aren't they? 80, 90, 100, 110. So this is 110. So if I go straight up, and if I kind of did a line of best fit here, this line of best fit would be something like that. What does it look like the total sales would be when you sold when you had 110 different rugs? It's perfectly fine. So I would say 35,000, right? Because that is where it looks like my 2 lines. So it looks like right here, looks like 35,000. So I've got my trend line. I'm making a prediction. Why do we do trend lines? Because we use them to make predictions. And that's what this multiple choice question is trying to get at. Yes, you can. However, I don't think I can do it on my screen because my screen is locked here. But you're absolutely right. You can do that on Desmos. Desmos does have that feature in there. But I think this is just a picture, so you really can't do that. I'll show you when we have the computers how to do that, or when we do Desmos. Okay. We aren't using the textbook. Oh, we are using the textbook. I mean, that the textbook is a tool. So if you are struggling with some of the work, you can always use the textbook. Textbook's always there. Okay, in this problem, it says Bianca is making homemade cards to send to friends and family and to sell at a local craft fair. This scatter plot shows the total number of cards she made after each hour she worked on the task. Okay, number of cards, number of hours. Using this information, what is the best prediction of the number of cards Bianca can make in 12 hours? All right, so now you really have to start thinking about this, right? Yeah, exactly. You don't have the data. Right. You just, I mean, you could figure it out if you wanted to. Okay, so, yep, you're going to have to expand this out, right? So what I would do is I'm looking at this, and this is a multiple choice question. You're just trying to predict. It's not, so I'm going to draw my straight line up this way. And then I'm going to draw, so 10, 11, 12 is here. So if I draw this up here, it looks like it's right about here. So I'm making a prediction, right? So 45, 50, 55, 60. To me, looks about 64, doesn't it? I mean, it doesn't look like it's going any higher than that. Okay. Do you guys agree that 64 sounds like a good answer? 54. Yeah, I think 54 is a little low because this is 50 right here, I would say, and this is a little 54. It looks like it's up a little bit higher. Now, I could be wrong. I mean, I've been wrong before. But I'm going to go with 64. It would have been nice if they would have extended the graph out a little bit more, so we'd have a little bit better of an idea. Yeah, it would have been really nice if they extended that graph out a little bit more, but they didn't. So we'll go with what we have. All right, number 5. It says the graph shows a population of a 5 square mile area called Miller's Flats, just outside a city's urban growth boundary from 1992 to 1998. Okay, so here it is. This is year. This is the population in thousands. Assume that the population of the Miller's Flats are a continuous growth at a fairly steady rate as shown in the graph. What is a good estimate of the population in 2001? All right, so this one's a little bit easier, right? Because 2001 is right here. So I'm just going to draw a line straight up. Well, guess what? If I draw this line, a line of best fit is a line that goes through most of the points. So it looks like it's right about, I mean, my graph is not the best, but what do you think the population should be about? Okay, using my graph. Letter B, which is 65,000 to 75, or I'm sorry, that would be thousands. Yep, whoa, that's thousands. 65,000 or 6,500 to 7,500. Okay, I agree with that. To me, that looks about right. To me, it looks more like 7,000. It looks like it might be a little bit higher, but 65 to 75 is where it is. Awesome. So these types of problems, pretty easy when you're predicting things if they give you a graph. All right. Which inequality best represents the domain of the function shown in the graph? Okay, so now this is your turn. I want you to go to Desmos. Now, obviously, some of you are going to look at this and you're going to say, Mr. Shanklin, there's no work to do here. I'm just going to circle the correct answer, which is fine, okay? Just circle whatever answer I just want you to get used to going back to Desmos and back and forth, okay? Okay, so all right, so I'm going to go into Desmos. I'm going to take a look and see Okay, so I got to go to the right slide. Ah, okay, so I'm not on the right slide yet. Oh, you guys are amazing. You guys are doing all this together. Excellent, awesome. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, more. Awesome. Okay. All right. I was going to say, I thought we had more than 9 students in class. Now, I will tell you guys, we have 110 students in Algebra 2 this year. There's only 21 here today. I would assume next Monday we'll probably have a few more because it's Monday and it's our normal session time. But there will be 110 students in here. Now, I wouldn't expect more than 40 to be here anytime. That's usually about how many I get in each session. Okay, so these are open dots, right? We're using inequalities to answer the question, right? So I know that my inequality, and I'm doing domain. So when I do this problem, I'm using inequalities. So I'm going to go this is how I would start this problem, right? Because I know that they're open dots, so I know that this is a less than symbol. It can't be less than or equal to. And then my farthest point over here is -3, so I put -3 here. So this is read x is greater than -3, and x is less than, what does that look like? 6? Does that look like 6 there? So that would be my answer for that one. Okay. So my answer would be letter B. Is that correct? Is that what everybody else had? I could go in and I could look in the Desmos presentation. Looks like the majority of people had letter B. I do see an A and I do see a D. For those of you that had A and D for an answer, do you guys understand why? Now I could see A. D kind of messes with my head. D, that person, can anybody tell me what the person that put D down was doing? As a teacher, I look at the answers and it's like, okay, if somebody put letter D down, they were doing the range. They weren't doing domain. They were doing range. Right. Exactly. They were doing the y-axis and not the x-axis. Okay. Open dot is open dot. An open dot would be the less than or greater than symbol. A closed dot would be less than or equal to or greater than or equal to. Okay, and then an open dot would be a parenthesis, and a closed dot would be square brackets. Okay, so that's how you want to remember those things. B was marked wrong in the actual practice. All right, that can be taken care of real quick. 1 second here. Let me, I'm going to go into the actual practice right now. Does your teacher ever make mistakes? Oh, yes. Your teacher makes mistakes a lot of times. So if that ever happens, just email me and say, Mr. Shanklin, you told me that it was this and you were wrong. There are times I am wrong. No. I'm going to go to number 3 too. All right, so there are times that my answer keys do not match up with what we're saying. So I'm going to check this out. Okay, so what number were we on? We're on number, yeah, my answer key had letter A. I must not have seen the open and closed dots there because that is definitely an open dot. That answer should definitely be C, right? So I'm going to go in, I'm going to change it, submit. So now that answer should be correct. Sorry about that. I do make mistakes. I will not I will not say that that I'm always correct, because I am not always correct. All right, let me see if I did that right, because somebody just saying B to C. Oh, darn it. It was supposed to be B. Darn it. I just changed number 6 to C, and we already said it was B, right? Mr. Shanklin, get with it. All right, so my answer is B. All right, so hit submit there. All right, sorry about that, guys. Okay, that should be right. All right, so number 6 should be letter B. Okay. All right. All right, so let's go to the next multiple choice question. Let's go to number 7. Number 7. Oh, now there's an arrow at the end. It says, which inequality best describes the range of the function? Okay, so now we have to be very careful. There's a closed dot and there's an arrow. All right, so which answer should be correct? Why is y? Why is y? I don't get that. Why is y? Oh, we have somebody that says B, somebody that says D. It looks like it's if my eyes are correct, okay, this looks like it's over 1, 2, 3. This looks like 3 here, okay? So it's in an inequality, so I'm going to, and, oops, I'm sorry, it's this way. It's range. I'm dealing with range, so that's a 2. Boy, Mr. Schengen, if you could teach, you'd be awesome. All right, so it should be y is greater than or equal to positive 2. Because remember, the range is your y-axis. How low does it go? Well, it only goes down to 2, and then it continues going up. So y is greater than or equal to 2. So whoever said D to start with, you're absolutely correct. It should be letter D. Does everybody? So for those of you that said 3, do you remember it's the y-axis? It's the y-axis. And yeah, your teacher makes mistakes. Ah, shame on me. Okay, onward. All right, so number 8 on the practice, it says which best describes the range. All right, so I'm gonna underline range. So when I think of range, I think y-axis. So it looks like it goes. This is the highest it goes, and then it's gonna go down forever because these arrows are telling me that it's going down, down, down. So I'm thinking y is less than or equal to positive 2. Does that make sense? Does that make sense on how to find the range? Ah, we did it. We got one right. Woo woo. All right. All right. You guys are making me laugh too much today. B, so many levels wrong. I would agree with you. If you chose B, there'd be so many things right because you've got the X instead of the Y in the first place. Because remember, the range is the Y, so you should always have a Y in there. So right away, I could have crossed off, you know, it's multiple choice. They're asking for the range. It can't be an X value. So B and C are gone already. So you only had, when you think about it, you only had 2 choices, A and D. It would be 2 to negative infinity. If you wrote it out as a, if you wanted to write it out as a interval, you would do negative infinity to 2. However, oops, and this should be a rounded one. This should be square. However, that's not how the answers were given. So right away, I decided I wasn't going to use that interval notation. I was going to use inequality notation because that's the way it was written. So you would be right. It would be 2 to negative infinity. That's right. But since the answers are in inequality form, we've got to put our answers in inequality form. Okay, number 9. Which of the following best represents the range of this function? Oh, this is a good one. I like this one. I'm not going to say anything. That means I'm going to turn off my mic and let you guys decide. Okay, and just put your answer in the chat box, and we'll. All right. I think some people right off the bat wanted to go with B because they were looking at the domain, right? If I wanted to know what the domain is, then you start looking at the x-axis. But this is a y-axis. So if I was going to do this problem, the first thing I looked at is like, okay, this is dealing with range, so I'm gonna, this is the lowest it ever goes. That's the lowest on the y-axis. This is the highest it ever goes. So I know it's going to be between -2 and 2, but now I have to decide close dot here, open dot there. So if I'm going to do this, close dot, open dot, I've got -2 to +2. That is how I would go about doing that problem. This is my closed dot, this is my open dot, this is the lowest on the left, this is the lowest on the right. If you were going to write this out in domain, in interval notation, would this be correct? Oh, that's not what I wanted to do. Is that correct? Why not? Why isn't it? Now, I wouldn't mark that wrong. I would not. But it really should be, when you're doing an interval notation, it always should go from the smallest number to the largest number. And I've seen kids doing this, and it's like, flip it around. But I did not take off points when kids did that. Okay, I left it, but it gives me gray hair. It's like, you should always go from the smallest number to the largest number. But you know, I didn't take off if they had the parentheses and they had the right numbers and they had the square brackets. I was okay with it. Didn't like it, but I did not mark it wrong. All right, number 10. Mary deposits $550 in a savings account at 3%, simple annual interest. The value of this account, V, is given by the function V is equal to 550 plus 16.5 T, in which T is the number of years the money is in the bank. What is the range of the function? Okay. Range. If I graph this thing out, okay, and that's what I start thinking about when they ask me a question like this. If I graph this thing out, Mary deposits $550 into account, blah, blah, blah. Year 0, let's say that this is year 10 here, okay? The value of the account. So if you put in 0 for time here, you'd start at 550, wouldn't you? That's where your graph would start, and it would go up like this. Wouldn't it? If you really think about it, if time was 0, she had $550 that she deposited. So now, what is the range of the function? Well, the lowest point is 550. I don't know what the highest point is, but it didn't ask me that. It just asked me what the range would be. I would say that the range would be V is greater than or equal to 550. That would be my range, and that's how I would think through a problem like that. It would be like, okay, at time 0, how much is in there? Well, we knew that she deposited 550 at the beginning, so that's the lowest that could go, but then it could keep going up and up and up. So I would say that the answer to that one would be V is greater than 550, or letter B for my range. That was a tough one, no question about it. Okay, now I'm going to go in a whole different direction right now, because you have to know how to graph a function on. I'm right? You have to be able to graph a function. I just want to go back to the assessment for this week, because I'm almost positive you have to do Desmos this week. Okay, so let's see here. Okay, last problem does have you do that. Okay, so I'm gonna walk you through a problem very similar to what's on the assessment this week. I'm gonna turn this off. And I'm just gonna make up a problem for you guys. Okay, if that's okay with you guys. Let's go week 2. This one here. Oops, I don't have a blank sheet of paper. Darn it. Okay, so we're gonna go with this one. Delete that. All right. So let's say that I did let's say I did a lemonade stand. Okay, I'm just making this up as I go. And when the temperature was 70 degrees, I sold 10 cups of lemonade. So degrees and number of cups. When it was 80 degrees, I sold 20 cups. When it was 90 degrees, I sold 30 cups. When it was 100 degrees, I sold 40 cups. Okay? That's that's my quick problem. So if I graph this, let's say that this is 70, 80, 90, 100, 100, we don't have to go up to 110, 10 cups. So let's just say that this is 10, 20, 30, 40, 50. So it's going to look something like this, right? So this week, it's going to ask you to write a linear equation through that data. Not by hand. It wants you to use a calculator to do it. It wants you to use the Desmos graphing calculator to do that. Okay? So I got to write these numbers down so I don't get this wrong. 70, 80, 90, 100, 10, 20, 30, 40. Okay. So what you're going to do is you're going to get the Desmos calculator out. And I don't have it up and running right now, so let me get that up and running for you. And I'll show you exactly step by step how we're going to put the data into the calculator and how to write the equation for it. Okay. All right. So I need to I need to share here with you guys. Okay, so I'm sharing the Desmos calculator. Okay, can you guys see the Desmos calculator that's up there? So the first thing I have to do, and this is problem number 4 on the assessment, okay? Problem number 4, first thing you have to do is you have to insert the data, okay? So I'm going to insert the data. Here's how I do that. I go to this little plus sign, I get table. I click on table, and then I put my x values in. My x values were the degrees, right? So 70, 80, 90, 100, right? Oh, no. Oh, it just automatically put in 110. I don't want 110 in there. Let's get rid of that. 70, 80, 90, 100. Okay. And then number of cups of lemonade I sold, it was 10, 20, 30, and 40. All right. So far, so good. So will you guys be able to plug the data in? Yep, very simple numbers, right? that way this old man won't forget the numbers. Okay. All right. So I've got the numbers in. Now I have to write an equation. Well, this is it specifically tells you to write a linear equation for the data. Okay? Linear. That means your equation should be in the form y is equal to mx plus b. That is a linear function, right? If I asked you to do a quadratic, you would do y is equal to ax squared plus bx plus c. But it's linear, so it's y is equal to mx plus b. And I'm saying this because I can't write on the screen right now. So I'm going to go back to Desmos, and I'm going to tell it that. I'm going to tell it that I want it to write an equation for this data. So here's how I do that. I tell it y1, because if you take a look at the table, my values are y1 is equal to mx plus b. Because remember, a linear function, slope-intercept form is y is equal to mx plus b. So I'm going to put mx, but guess what? I can't just put x there. I have to put x1 because that is what the table tells me. Oh, I'm not right yet. You can't use an equal sign here. Sorry about that. You have to use a tilde symbol. Yeah, now I know you guys watched it, or Samantha, I know you watched it because you're telling me I have to put the tilde symbol in there. Yes, I do. Some kids are going to say, tilde? What is a tilde symbol? All right. You go down to this little keypad. You go to ABC on the keypad, and this little squiggly line, that is called a tilde symbol. So I'm going to put tilde in there. So y1 tilde mx1 plus b. And guess what? I just came up with my equation. Can anybody tell me what the equation is of this line? Okay. What is my equation of this line? And remember, my equation was y is equal to mx plus b. They just figured out what M is. They just figured out what B is. So now all you do is you just write it as an equation. Y is equal to 1x minus 60. That is exactly right. That's my equation. Okay? It figured it out for me. It figured out what the M value is, what the B value is. Okay? So I just write it as an equation. Now, here's where it's really cool. I'm going to put that equation in. Y is equal to 1x plus or minus 60. Now, my line should go directly through those data points. Mr. Schenkel, I don't even see the data points. Let's make this graph a little bit bigger. Oh, my goodness. My equation of my line just went through all those data points. Isn't that cool? That is amazing. Now, here's what yes, this is called the line of best fit. Right. Now, most of the times the data isn't that straightforward. I mean, the line's not going to hit every single point, but that's okay. Y is equal to 1x plus negative 60. That would also be fine. Yep. So now, this is, if you take has anybody taken a look at the assessment yet? I mean, you guys all have the answers to the practice, right? So once you hit that, the assessment should open. Okay. Nicholas, are you looking at problem number 4 right now? Is it very similar to this? It asks you to put the data in. It asks you to write an equation. And then the last thing it says, okay, how many cups of lemonade would you have if it was 130 degrees? Okay. There's 4 questions on the assessment. There always is 4 questions. But now, like problem number 1 might have like 3 graphs that you have to give me I'll show you the assessment in just 1 second, okay? I'll do that too. Okay, so now let's say it was 130 degrees. How many cups of lemonade would you sell? Well, guess what? I could just put 130 in here, right? If I put 130 in here for X, I get rid of that 130, I should sell 70 cups of soda or cups of lemonade. Now, I could have also went over to 130, 100, 110, 120, 130. I could go straight up, and this is my point, 70. Oh, look at that. The calculator does all the work for you, as long as you understand how to put the information in. For those of the students that did not watch the lesson tutorial, did not come to the main lesson, I'll bet you they will not get this answer right, because they will not know how to put the values in. Okay, so it is a good thing to come now to these sessions. Now, what I'm going to do is I'm going to leave here. I'm going to go back. There's one more thing I want to show you guys before the hour is up today. Okay, I'm just going to go back here, share files. Nope, that's not what I want to do. I want to share my screen. Desmos. Okay, so I'm going to show you guys what's on the assessment for this week. Okay, and I'm gonna ask you guys a question. Am I trying to trick you? So let's go here. All right. So do you guys see my screen? I turned on. Oh darn it! Okay. So what I did is I turned on the assessment 2A. Okay. This is the assessment for today. One of them. This is the free response one. Now, if you don't know how to show your work in class, you can always hit this assessment 2A, and it has all these problems, but on a sheet that you can write on the computer. So if you wanted to do it that way, you can absolutely do it that way. If you don't know how to insert work into an assessment, this is another way of doing it. So problem number 1, state the domain, the range of the graph, and if it's a function or not. Should you guys be able to do those problems? Which do I prefer? It doesn't matter. A lot of students, they don't like writing on the computer, and a lot of students, they like to do it on paper and pencil, but some students haven't figured out how to insert their work. Now, this week, there's not a lot of work to show, right? So, for example, let's say I didn't know how to show my answers. I could go up here. I could just, you're not going to be able to see it because it'll open in another window. and you'd be able to write your answers down right away, right on the screen. But there's not a lot of work to show here. I mean, you just write your domain, your range, is it a function or not? Problem number 2, look at the graphs. Where is it increasing, decreasing, constant? Is it continuous or discontinuous? I guess we didn't talk about that. Continuous means that you could draw the graph without lifting up your pencil. That's a continuous graph. A discontinuous graph has a hole or a gap in it. So in this problem, is it a continuous graph? Well, if I drew it, I wouldn't have to lift up my pencil at all, would I? This is a continuous graph. Here, if I put my pencil down and I went along it, I can draw it without lifting up my pencil. That's what it means to be a continuous graph. End behavior just means what is the graph? Oh, good question, because it's not there. End behavior just means what is the graph doing at the very end. Okay, so let me go to this graph here. You have to understand that if there's not a dot, an open dot or a closed dot, that this graph just continues. Oh no, I can't draw on that. Oh no. Okay, so it just continues up. Okay, so what is the end behavior? As x goes to negative infinity, so as you go farther and farther to the left, this graph goes farther and farther down, right? So y goes to negative infinity. As x goes to positive infinity, so as x goes bigger and bigger, I'll do a problem just like this on, I'll do it on the whiteboard in just a second, okay? I'll show you exactly what you should be writing down. Okay, and then problem number 3, you're just supposed to graph this out with the domain -1 and 2. So remember, open dots and closed dots. And number 4, data, put it into your calculator, graph it out. That's the assessment for this week. Okay, so let me go through. Oops, I don't want to do that. I want to do this. It takes me a while to remember how to do all this stuff here. All right, so I want to share files. Week number 2, share that. Okay. So let's say this is what they give me, and they ask me for end behavior. Okay, so let me draw a function in here. Okay, so there's no dots, so that means that this goes down and this goes up. End behavior, it always asks you when x goes to, let's say, negative infinity. So this is the x-axis right here. This is negative infinity here. This is positive infinity here. So as x goes to negative infinity, what's happening to this graph? The farther you go to the left, where's the graph going? Okay, that's what they're asking you. Okay, to the left, but we want to talk about the y-axis. Okay, so we're talking about the y-axis here. So this is negative infinity here. This is positive infinity here. So as x goes to negative infinity, it goes down, right? But you would say y goes to negative infinity because it's going down. It's not stopping. Now, if it stopped, let's say it stopped right here, right at -10. So as x goes to negative infinity, y goes to, it would just be -10, wherever that graph is going. So now as x goes to positive infinity, where is this graph going? It's going up, right? But what would that, on the y-axis, what would that be? So it's going up, 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 up. So it'd be, so as x goes to positive infinity, so it's going this direction, the graph is going to positive infinity also. It's going up. It's only week 2 and you have more work than the middle of last year. Your teachers must have been too nice last year. Question 4 on the assessment is what I would suggest doing is once I have this recording in, I would go back and I'd watch the recording because we did a problem exactly like number 4. And usually number 4 are the advanced questions, and I never talk about the advanced questions because it is advanced. But I went through step by step how to do problem number 4 on this week's assessment. So I would go back and I would check it out, okay? Yeah, And that's the problem, is that it's Wednesday already. Next week we're going to be right back on Mondays, and we'll have all the time. Now I do have to get going because I have another class coming up. Normal week next week, yes. And I hope to see all of you there next week. I enjoyed Monday out on the lake. All right, you guys have a great week. We'll hopefully talk to you next week. Bye.